I hope you had a good day of workshops yesterday. And if not, I hope you're going to have a good day today with the conference. But let's just jump into it, shall we? This talk is about how to use Git effectively, or rather how effective teams use Git. My name is Enrico Campidoglio. I'm a freelance programmer. This is me freelancing from home these days. I also do a fair bit of training, workshops and stuff like that. And these days I also do that from home. Who would have thought? Anyway, we're not here to talk about that. We are here to talk about Git. Now, it's never been a better time to learn Git. These days, there are plenty of resources out there. You have books, videos, you have online tutorials, you have even podcasts about Git. So with all these resources, I mean, getting off the ground is not a problem. But while everyone, including me, is busy telling you how Git works, nobody is giving you any advice on what to do with it. So that's a problem. You might wonder, okay, what do you mean by that? Well, I mean that if you know how something works, it doesn't mean that you necessarily know how to use it in practice. For example, it's like learning how to play the notes on a piano, but then you cannot play a song. So what you need is guidance. But wait a minute, you say. Who will need guidance using a source control system? I mean, it's pretty self-explanatory, right? And you would be right. It has been that way with traditional source control systems, like, for example, CVS, Perforce, Subversion, even TFS. Those source control systems, by virtue of how they were designed, they were pretty much telling you how they wanted to be used, and there was no other way. Git, however, is different, because Git doesn't really have an opinion about what you do with it. I mean, Git is just a content tracker. It says it right in the manual, right? A stupid content tracker. It tracks the content of your files, and that's it. How you use it in the context of software development, that's completely up to you. So instead of Git telling you how it wants to be used, it's more like, whatever works for you. I'm just a content tracker. So yeah, we need some guidance. But where do you find this guidance? Well, there we have the second problem that, everybody uses Git in a different way. Depending on your project, depending on the size of your team, what kind of software you're building, those are all things that affect the way you use your Git and how you do version control. So in order to learn how to use Git effectively, what you can do is observe how others use it and learn from their experience, see what works, see what doesn't work, and write things down and apply to your own. So that's what I have done. So what is this talk about? This talk is about, it's a collection of, you could call them habits, ideas, things to think about that are coming from people who use Git to improve their workflow. People who are really good at being productive using Git. And they do it both individually as well as a team. So you can see that you can think of this talk as a collection of things that you can bring into your own experience and see how they apply to your workflow and to your project. So let's get started. I said that these advices and these ideas that I'm going to share with you today, they apply both individually as well as in a group. Because Git, being a distributed source control system, every repository is equal. So there are things you can do on your own machine. These I call personal workflows. And then there are the things that you do with the rest of your team. and those I call team workflows. So the content of today, I divided into these two categories just to, to keep them clear. And to be more specific, I give you 3 pieces of advice for personal workflows and then 3 more for team workflows. All right, sounds good? I hope it sounds good because I can't see none of you. So I'm just gonna take it as a yes. So let's start with the personal workflows. Let me just jump right over to the demo. So what you are seeing here is a command line. Oh, by the way, I forgot to mention that the things I'll show you today, I'm going to use Git from the command line to demonstrate these things. However, most of what I'm going to show you applies just as well if you're using Git from through a GUI, through a graphical user interface. And if it's something that just applies to the command line, I'm going to tell you. All right. First advice that comes from teams that use Git effectively on personal workflows is to get comfortable. Now, it actually means configure your environment. Git is a rather complex tool, to say the least. So there is no need to make it any more uncomfortable to use than it already is. And there are many options and configuration settings you can apply to your environment to make it a more pleasant tool to use. The first I want to share with you is, and this applies to the command line, is to install a Git-aware prompt. So what is that? It's what you're seeing right here. If you're sitting in a command line, there are utilities you can install that will enrich your prompt with information that comes from a Git repository. For example, you will see the branch you're on, and as we're going to work with our files, this prompt will show us the number of modified files, stuff like that. So what kind of prompts are there out there? So if you are using Windows and PowerShell, I recommend you install PoshGit. And if you are on Linux, or if you're using the Windows subsystem for Linux, and or you're using, for example, Cygwin on Windows, if you're using Bash, I recommend Bash Git prompt. If instead you're looking for something cross-platform, I highly recommend, and this is my favorite, something called Starship, and it's the one you're seeing right here. Starship is a cross-platform console prompt, Git-aware, which is also written in Rust. So, extra bonus for coolness factor. The other thing I want to share with you is how to get pretty diffs in your prompt. So, you're going to be looking at a lot, and this also applies just to the command line. You're going to be looking at a lot of diffs if you're working with Git. And, the diff format, everybody knows how it looks like, can sometimes be hard to read. So there is an utility you can install that prettifies your diffs in the console, and that is called Diffsofancy. This comes in an npm module. So you say npm install Diffsofancy, which I already did. And once you have it installed, you need to tell Git to pipe all the diff information through Diffsofancy before it gets printed onto the console. And you do that through a configuration setting called pager. So you say git config core.pager, and you basically set it to Diffsofancy, and then you pipe it to less to print it onto the screen. And once you've done that, you can basically say, for example, you can say diff, the commit that's in head, that's referenced by head, compared it with the one before head, and you get something like this. So you see, first let me show you how it looks like if you skip the pager, where you tell Git, don't pipe the diff information through the pager. This is how a normal regular diff looks like. And once you have Diffsofancy, it looks like this. So you see all the plus and minuses are removed, and it even highlights exactly what in the file, in the string has changed. Plus it gives you this really nice header up here. So Diffsofancy, good stuff. The next one has to do with whitespace handling. Now, as programmers, you know that whitespace matters, and it matters a lot. And especially you need to be consistent with your whitespace usage. Well, it turns out that Git has built-in features to help you keep your whitespace consistent throughout your files. What you need to do is tell Git what's invalid whitespace. And you do that through an option called core.whitespace. So in this case, I said that I don't want any blank, I don't want any white space at the end of a line. I don't want any white space at the end of a file. And the regarding indentation, I don't want to see any tabs in indentation. Instead, I want to see spaces like it should be, right? So you're telling it what it should consider invalid white space. And after you've done that, you can use git diff with the check option to check for invalid whitespace. So let me give you an example. Let's open up so this is just a console, a .NET Core console application. Let me show you real quick how it looks like. I have a CS proj file and a command line program written in C#. Pretty simple stuff. So let's open up the source code, and let's make a change right here. Let's, for example, do like this. And then on this line right here, let's add a bunch of white space at the end of a line. So you see, by the way, that Starship has updated my view. I have a modified file. Oh, there you go. And so let's do git diff check. And you see that Git is showing me I have invalid white space exactly here at the end of the line. So that's pretty cool. However, you need to remember to invoke it, which doesn't always have to be the case. So if you're going to be effective with Git, you need to, as we're going to see later, automate as much as possible. So let's say that I want to go ahead and I forgot to check for the white space, and I'm just going to commit the file and add some invalid white space. What happens if I happen to commit some invalid white space? Well, no worries, because you can use the rebase command with the white space option equals to fix, and Git will go through the commits included in the rebase and automatically fix any white space errors for you according to these rules. So let's take a look at our latest commit. You see that I have the invalid white space here. And now let's do a rebase. Let's start it from the root of the repository just to be sure. And then I'm going to say white space equals fix. Oh, sorry. Git rebase. Let's start 2 commits ago and then say white space equal fix. So you see that the last 2 commits have been reevaluated. And let's take a look at and the white space is gone. So pretty cool stuff to be effective, to use the Git features to be effective. The next one is conflict handling. It's a fact of life that you're going to have merge conflicts, especially with Git being a distributed source control systems where everybody is working asynchronously from each other. So Git has some top-notch features to handle conflicts. One of them is something called three-way merge. Now, let me get rid of the artifacts over here. So I have a branch called feature that, let me just highlight it for you. I have a branch called feature that I want to merge into master. And there is a conflict in the commit referenced by feature. So let's see how a normal conflict resolution looks like. You say git merge feature, and you see here that I have a conflict in the program.cs. Now, if you take a look at what I have in my working directory, you see that Git is gonna enter the so-called merge conflicts headers, where it's telling me, okay, this is how the conflicting lines look like in the commit that you're merging into, and this is how they look like in the commit that you're merging. And you see that one commit, let me see if I can highlight it here. One commit is adding a comma, but keeping the exclamation mark, and the other one doesn't have the comma and doesn't even have the exclamation mark. So what is it gonna be? Now, if you're gonna resolve a conflict, it's useful to see, yeah, but how did it look like before either of those commits? In other words, how did these lines look like in the commit that's the common parent of the conflicting commits? And that's where the three-way merge comes in. Because three-way merge means you're not only comparing two sides of a merge conflict, you're comparing two sides against each other and against their common parent, three-way merge. Now you can tell Git that you want to do a three-way merge by setting the conflict style option to diff3, where the 3 stands for three-way merge. So let's do that. Let's first abort this merge. And now we are going to say git config conflict merge.conflict style diff3. And now let's do the merge again. Still getting the conflict, of course. Let's see how this looks like now. And you see that now I have an extra set of lines right over here. And this is how the lines look like in the common parent. So now I have a better, you see, before it had the exclamation mark. This line removes the exclamation mark, and this line here adds the comma. So now I have a much better context to resolve the conflict, which makes me more effective. So that's it for merge conflicts. Let's move on to global ignores. Now, you might have noticed before that if I open up the file, now this is Vim, but I have installed OmniSharp, which is basically giving you IntelliSense inside of Vim and other editors. And after a while, if you see, if I edit this file, after a while, I'm gonna get like, and here we go. You see that I'm getting warnings and I'm getting compiler errors. I bet nobody spotted that one before. So this means that my code has been compiled in the background. So if I exit this file, now I have, you see over here, I have an untracked file. And what file is that, you might wonder? Well, it's the object directory. The object and bin have appeared because the OmniSharp has compiled my code in the background. And I have no git ignore. So that's why those appear as untracked. Now, if you're going to work with the same kind of language and the same kind of technology stack, that means that you're going to have the same kinds of files and directories that you want to ignore in all of your projects. For example, if you're working with .NET, you're always going to want to ignore the obj and the bin directories, because in those directories, you have the binaries. Now, rather than having the same content everywhere in all of your git ignores, you can have a global git ignore that applies to all the repositories on your local machine. And so what it is, it's basically a git ignore that you put in your home directory. And then you tell Git to use that as the global ignore file by setting the core.excludes file option, which I have here, excludes file. So you see that it's in my home directory. So what we can do in this case is that we can open up the global git ignore. And right now it just contains everything that starts with tilde and this directory. And we're just going to add bin and obj to the list of the global ignores. And you see that immediately, without doing anything, before it used to be untracked, and now it's gone. And as you can see, I still don't have any git ignore in my directory. So it's already ignoring bin and obj. So very useful if you're working, which is not likely that you work with the same kind of language and the same kind of frameworks, to have a global ignore on your machine. The last one of the get comfortable set of advice is always push new tags. Now, you might be surprised to know that when you create a tag, which you probably do when you want to release a version of your software, is that new tags don't automatically get pushed by a regular git push operation. If you want your tags to come along with the push, you need to pass the follow tags option. Now, chances that you're going to forget to do that are very high. So by setting the push.follow tags option to true, new tags are always going to automatically be pushed for you. Switching gears. There you go. The second group of advice that I want to give you when it comes to personal workflows, in order to be more efficient, is to craft your history. And what do I mean by that? I mean that you need to create commits that are readable and that make your history easy to follow for the future generations and for the future you, of course. Now, how do you create good commits, you might wonder? Well, good commits have a set of properties that I call acid. So I'm going to go through this, what acid commits are. And by the end of it, you're going to have a pretty good idea of how to craft your commits so that they make your history easy to read and easy to follow. So the A in ACID stands for autonomous. Good commits should make one logical change that is independent from other commits. That means that commits should be cohesive. That not only should they make one change, but all the changes inside a commit should be related to each other. Now, how do you use Git to make autonomous commits, you might wonder? You use something called a patch commit. Now, let me show you what I mean. Let's open up our file again. And you see that right now, let's say that I want to make two changes. I want to, for example, fix this bug that we saw before. And also, I want to, you see over here, this is telling me that this using statement is unused. So you do a cleanup, I remove this line, And I then also want to fix the bug. So now if I do a git diff, now I made two changes. I made one change that affects the functionality of my software that didn't compile before, but after this commit is going to compile. And then I also made a cleanup that doesn't really affect the functionality of the code. Now, these are two different changes, two different kinds of changes, and they should be into two different commits. But however, I made them into the same file. So how can I split my changes into different commits? That's where the patch commit option comes in. So what you do, instead of saying git add and then your file, like you will normally do, you add the -- patch or -p option. And what happens is that Git is gonna see what changes you made and ask you for each of them. Do you want, well, it's not it's not really asking you anything, right? Because Git is cryptic. But what this means is, do you want to stage this hunk? That means, do you want to add this change to your next commit? And then you have these options over here. So you might guess that Y means yes. So do you want to add this? Yes. What about the other one? By the way, I also have whitespace error. So yeah, let's keep it for the time being. So do you want to add this one? I say no. And what I have now is that I have a split. I have a split situation. The same file is partially committed and partially is partially added to the stage area and partially still in my working directory. How do you find out what's in the staging area? You say diff cached, and you see what I'm about to commit is just the cleanup, and what I have in my working directory is the change that I made to the functionality. So now I can just say git commit, and I say removes unused using. And then I can just say commit all fixes the compiler error. So now I split the two changes into two different commits using the patch commit. The C stands for correct. Good commits should not break the state of your project. That kind of intuitive, but by having commit that are correct allows you, to pick and choose commits from different branches and apply them to your own branch without being worried that you're going to break your software. Now, how do you ensure that what you're about to change, that what you're about to commit doesn't break the software? Well, you have two options. The first one is to use save keep index. So let me just undo what I just did now, the last two commits. And let's try it again. So let's open up this file. Now I'm just gonna do remove this, and then I'm gonna make the same change over here. Now I have these two changes again. And let's again add the, let's just add the first one. So we say add p program. Do we want to commit this? Yes. Do you want to commit this? No. Now, what you want to do is that you want to compile, run your tests, do everything that's necessary to ensure that the change you made doesn't break your software. However, you just want to include what's in the index, in the staging area. You don't want to include any other changes that are not about to be committed. So how do you do that? You basically stash away everything that's not in the index and keep what's in the index in the index. So you say git stash save keep index, Then I say fixes the compiler error. And what I have right now is that you see this change is no longer in my working directory. It's gone. What I have is I just have what I'm about to commit. So now I can say .NET build, for example, or run the tests and everything to make sure that what I did doesn't break the software. Oh, there it is. Of course, this is the error from before. So yeah. Actually, let's do the other one. Well, you get the point. Let's do the no, let's do the other change. Let's do this, and let's do this. So I should have committed to the other one. So let's make these two changes. We go line. So let me just do the patch commit again, where you say, do you want to commit this? No, this time. Yes, this time. Now I have this split situation. And I just want to check that the error that I corrected works. So let's stash save the message. Now I'm gonna stash away the removes the unused using and keep the index. Perfect. Now, let me see what I have staged. I have just the fixed error over here. And now I can verify that what I'm about to commit indeed fixes the problem, and it does. So I can safely commit it, fixes the compiler error. And then I want to get back what I've stashed away. So I say git stash pop. And now I get back the file that I had before, and I can continue working. Moving on, if you have a list of commits like this, how do you make sure that what you have, every commit by itself doesn't break the software? Well, what you can do in that case is that you can, again, use the rebase with the --exec option. And what I will do is that, well, let me just show you. Let's start a rebase from the beginning of the history in this case. And you say that for each of those commits, you want to run a command. What command do you want to run? You want to run the .NET build, for example. And let's just make it interactive so I can show you what it does. You see that for each of the commits, Git is going to add the command that you specified after each one. So what happens is that for each individual commit, Git is going to try, in this case, to compile and see that does this commit break anything? And if it does, it's going to stop and give you the chance to fix it. So let's just save this file, and you see Git goes back to in the history, runs the command for the first one, then runs the command for the second one, and here it breaks because this is the commit that introduced the error. So at this point, you see that indeed this is where the problem started. So you can fix it and then continue the rebase. So this is a really good way to make sure that each individual commit doesn't break the history of your doesn't break the state of your software. The I in ACID, what does it mean? It means incremental. Now, if you have, if you're working on a branch with a bunch of commits, you want to make sure that the order of those commits is a logical progression of your work in that branch. so that it makes sense. What kind of changes you made and your thought process during those changes. Now, how do you do that? Well, you already saw it right now. You make an interactive rebase. So, for example, let's say that I want to make sure that the order of the commits that I have in my branch reflects my design process, my thought process. I say interactive. In this case, I'm going to start from the beginning. And once I have this list of commits that are in my branch, I can, for example, reorder them. I can squash commits into each other so that they become one if I have a bunch of temporary commits. In this case, I have this commit over here that fixes a compiler error that was actually introduced over here. So I don't necessarily, if I haven't shared those commits yet, I haven't pushed them, I have the chance to fix this history so that this one appears in the right order, or rather it's included into that one. So what you can do is that you take this one and you move it right below the commit you want to squash it into, and then you change the option from pick to fix up. And what this will do is that the Git will basically take this commit and include it into that one. Then you save, and hopefully you don't get a merge conflict during the process. That's because I've changed the other one, that line before. Anyway, once you, well, let's, no, I don't have time to fix this merge conflict. Once you reorder your commits, they will make more sense for everybody else to look at. The D, the last one, stands for documented. And what this means is that a commit should clearly state the state, should clearly state the change that it made and provide as much information as possible about the context in which the change was made. And of course, that's the commit message that you specify. Now, the third category of tips that I want to share with you about personal workflows is to automate. And you have already seen a bit of it. And automate means let Git do the work for you, basically. Now, you know about aliases. In Git, you can associate an alias to a command, or a command and a combination of options. For example, I have an alias that I use all the time called LG. And what this does is that it runs git log, and then it basically beautifies my history by including only certain information about a commit and then coloring it with different colors. So when I say git LG, I get a nice and tidy history. Now, you might be surprised to know that you can also associate shell functions to aliases. For example, one that I picked up years ago is one called undo. So let me show you how it looks like. You say alias.undo in this case, and you see I'm basically defining a function. You can call it anything. Well, first you say that you start your alias with a, let me see, there you go. Oh, wrong one. You start your alias with an exclamation mark, which means that whatever comes afterwards should be evaluated as a shell function. Then I'm defining a shell function called f, could be called anything. And the body of the function is a git command, which is accepting a parameter that I pass from the command line. And at the end of the alias, I just invoke the function. So what aliased functions allow me to do is they allow me to define shell function that can take parameters and associate them to git aliases. So in this case, the undo, it's gonna reset the head reference to a certain number of commits backwards in history. So for example, if I have this and I want to undo the last one, I can say git undo one. And now you see that I have effectively removed this commit and went back into the other one. So alias functions are a quick way to be really effective with Git from the command line. Git has also a lot of automatic features. You have seen that we can automatically push new tags, for example. So I call this auto this and auto that. Auto stash, what does it do? If you have files that are modified in a working directory and you start a rebase, Git is going to stop you and say, I can't rebase because you have uncommitted changes. Well, what auto stash does is that whatever you have in your working directory, Git is going to automatically stash away, do the rebase, and then unstash it afterwards for you. And then you have something called auto squash. This one I really want to show you. You saw before the squash operation that we did, where we moved one commit underneath another one. So you can also do that quickly instead of doing afterwards, instead of doing the work yourself. So let me show you how it works. So here, actually, let's get rid of this so that hopefully we don't get a merge conflict. And then we also fix the problem over here. So now I'm gonna stage the entire file. Now, if I look at the history, I know that what I'm about to commit now, I want to later squash it into this one, because that's the commit that introduced the error. So what I can do is that instead of just making a regular commit, I'm gonna say commit fix up, and then I have to tell Git, okay, which commit are you going to squash this into later? Well, I want to squash it into the commit whose message contains the word executable. And I'm using this special syntax over here. To say, squash it into a commit that contains whatever, whose message contains the word that I'm specifying afterwards. So when I do that, Git is gonna commit my changes and add the fix up exclamation mark at the beginning of the commit message, and then the commit message of the commit that is gonna be squashed into later. So what this means is that when I do a rebase, let me say git rebase interactive, you see that Git has automatically moved it to under the right commit because it has matched the commit message. And this is really useful if you want to fix a bunch of commits that happened before. You can just commit away and use the option that I showed you. And then when you do a rebase, Git is going to automatically move the commits in the right spot. All right. The last one of this is use client-side hooks to automate part of your workflow. So in every Git repository, there is a directory called .git, and underneath there is a directory called hooks. And these are all shell scripts that are going to fire at certain points in the history. That they're going to fire when certain things happen in your repository. For example, one event that is very interesting is the commit message event. This is going to fire whenever you are about to create a commit. And at this point, you can have scripts that run at certain point when you're using Git. And for example, the commit message is interesting because you can use it to evaluate the commit message that you're about to specify and to make sure that it follows the convention. Now, in this case, I have a script defined there in commit message that basically what it does is that it evaluates the commit message and makes sure that the first line is not longer than 51 characters or 50 characters, because that's how a well-formed commit message should look like. And if it doesn't, it's going to give me a warning and a chance to modify it. So let's try it out. Let's just do an empty commit just to demonstrate. And then I'm going to say this commit message is too long, definitely longer than 50 characters. And here I'm getting the event, the commit message script has fired, and I'm getting the warning that says, no, the first line in your commit message should be 50, but it's 63. Do you want to modify it, or do you just want to continue? And this is an excellent way to automate portions of your workflow through scripting. And that's it for the personal workflows. Let's move on to team workflows. And I have 3 tips for you here as well. So the first one is branching. Now, I'm not going to give you advice on which of the many kind of workflows you should use in your project. Git flow, GitHub flow, you name it flow. What instead I'm going to tell you is things you can think about in your team when you are deciding and when you are evaluating which kind of flow you want to use. And the rules for evaluating workflows are very simple. Be aware of the different kinds of branches that exist. Now, what do I mean by that? In Git, there are essentially 2 kinds of branches you can create. You can create long-running branches, or you can create topic branches. Now, let's take a look at an example. A long-running branch, every repository has at least one long-running branch, and that's, of course, master. That's the branch that exists for as long as the project itself exists. That's why it's called long-running. And usually it contains the work from multiple contributors. If instead you want to do some specialized work, for example, let's say that you're working on a feature, that is a branch that's going to exist for a short period of time, and that usually contains the work of one contributor, and it's focused on a specific task. That's why it's called a topic branch. Topic branches usually eventually get merged into the long-running branch, and then they disappear. So they are short-lived. When I told you that there are 2 categories of branches, it was not completely true. There are actually 2 more kinds of branches you can create. You can create public branches, and you can create private branches. Now, Git is a distributed source control system, which means that every repository is equal, but we all agree to have one copy. One of these repositories is deemed the canonical one, and that's usually going to be hosted on a central server, for example, GitHub or Azure DevOps. Now, a branch that exists in a shared repo is technically accessible by anyone, and instead the branches that exist on your local repo, that is on your local machine, they are only accessible by you. So a branch that's on a shared repo, like for example master, it's a public branch. And a branch that exists only on your local machine, for example, you are working on a feature just by yourself, that's a private branch. So to put it all together, you have long-running branches, and long-running branches are usually public. By the same token, topic branches are usually private. However, this is what usually happens, but it's not the only option. You can have long-running private branches. For example, you have an idea, you have an experiment you want to try out. However, you don't want to share that branch with anyone, but you keep it around for a long time. That is technically a private long-running branch. By the same token, if you have multiple people in your team working on, for example, on a user story, and that user story is being worked on in a topic branch, a focused branch only on that feature, then you're going to have a public topic branch. However, not all combinations are equally good. Long-running public branches, those are okay. Actually, those are necessary in the case of master. Topic branches that are private are also okay. However, keeping a long-running branch that only you have access to, keeping it around for a long time is a problem, because the longer you keep the branch around, the harder it's going to be to keep it in sync with the main branch that's being shared. By the same token, having topic branches that are focused on solving a particular problem and keeping them public, that is, multiple people are going to contribute to that, it's very easy to have people step on each other's toes, and you end up with merge conflicts and stuff like that. So that's not a combination that you want to have. So that means that long-running public branches, you should try to be conservative with them. Don't have too many long-running branches and don't have too many public branches. Keep that number of branches low. On the other hand, topic branches and branches that only you have, use them as much as possible, because that's what Git is about. Branching is cheap, and so you should use it to your own advantage. Now, the other tip is about merging. Now that you know that there are different kinds of branches, you should let the kind of branches you want to merge, you should let them decide how they want to be merged. So you have two kinds of merges. You have the so-called true merge and you have the rebase. True merge, of course, is when an actual merge commit is being created to tie two different lines of history. And a rebase is when you are changing the base of a branch and then merging it through a fast forward. Let me show you what I mean. A public branch that's going to be merged into another public branch. In that case, you want to have a merge commit between them, because you want to make it really visible when two public branches have merged together. If on the other hand, you have a public branch that you want to merge into a private branch, for example, you're working on a feature and you want to bring in the latest commits from master into your own feature branch, in that case, you don't want to have a merge commit, because that merge commit is only interesting to you. Nobody else is interested in that, since you're merging into a private branch. In that case, you want to do a rebase. For example, an example of this is a pull request that gets merged into master. You want that to appear as a merge commit. Or if you're merging master into your own work in progress branch, you want to have that as a rebase. Why is that? Let's say that you have a master branch like this, that is public, of course, and then you have a pull request that is also public because it has to be code reviewed. And you want to then merge the pull request into master. Now, the fact that you made it as a merge commit, when you later delete the pull request branch because that's been merged, if it turns out that there is a problem with that pull request, then it's easy because you can just revert the merge commit and you have automatically undone whatever came in through that merge commit. So in this case, having a visible merge commit makes it easy to undo whatever was done in that pull request branch with a single reverted merge commit, which in this case is set as represented with the W, because W is the opposite of an M. If instead you had rebased, that is, you have rebased your pull request branch into master and that you move master forward, if you had done that and then it turns out that there is a problem, you have to evaluate each commit individually to find out which of them introduced the problem. And if there are a bunch of them, that's going to be a problematic to find. And if the master branch has moved forward, it's going to be even trickier to undo them. By the same token, when you have a private branch that is a work in progress and you want to keep it updated with whatever happens in master, if you had done it through a regular merge commit, so you have a public and a private branch, then let's say that you have merged whatever came into master into your own private topic branch through a merge commit. What happens then later when you want to merge your topic branch into master again? Well, what happens is that you have a merge commit then again, because you're merging private into public. And you see at this point, you have a double merge. And if you do this enough, your history is going to look like this. And there is actually a name for this kind of history. This is called the Guitar Hero history. Why? Because if you look at it, it reminds a lot of how the strings look like in Guitar Hero or Git Hero. So you don't want to do that. The third and final thing to think about in your team workflows, has to do with releasing software. So now that you know that there are different kinds of branches, and now that you know the rules for merging these kinds of branches, now the third thing to think about is map these branches to your release environments. In other words, know where your branches are going. What do I mean by that? So let's say again that I have this master branch, and then I have another long-running branch, which is called develop. Now, you want to map these two branches to different environments. So for example, the develop, we're going to deploy whatever is in develop to a test or a QA environment where it's going to be verified. Whatever is in master, however, once we merge that work into master, we're going to push that into production so that it can be used by the customers. So this gives you a nice way to know what the changes that you're making in a certain branch, in what environment are they going to be deployed into. And you can also do different deployment strategies. So for example, in a develop branch where you're deploying to a test or QA, you can do that on every commit automatically. And that will be like, that's called continuous deployment, where you automatically continuously deploying your software to a test QA environment. For production, you can do that for production as well. However, since it's riskier, you maybe want to have that as an automatic process, but that is manually triggered. In that case, you want to do continuous delivery. That is, whatever is in master is always deployable at any time. However, the actual deployment process is triggered through an explicit and intentional action instead of happening it automatically. So let's wrap this up with 1 minute to spare. We talked about how effective teams use Git and how they use them in two categories. First, when it comes to personal workflows, get comfortable and configure Git so that it's a more pleasant tool to use. May take care of crafting your history by following the rules of ACID, autonomous, correct, incremental, and documented, so that your history is readable. And the third one is use Git feature to automate as much as possible of your workflow so that you have less work to do and it can catch any errors that might happen. The second category of things to think about has to do with team workflows, stuff that you do in collaboration with others. And this has to do, the first category of tips was be aware of the kinds of branches that there are and be aware of how they should be merged together. And those two rules, those two things, if you think about them, they're going to guide you when you're evaluating different kinds of workflows to use in your team. The third one is be aware of where the code that's in every branch is going to end up in, and have a clear mapping between branches and your deployment environments. And with that, I want to just let you know that what I showed you today, there is much more than that you can do with Git. And I have a Pluralsight course out that's called Advanced Git Tips and Tricks, where I cover these things and much more. So there is the link over there. And also, I want to remind you that for the month of April, you can watch as much Pluralsight as you want for free. So there is that. And with that, I want to say thank you for watching and enjoy the rest of the conference. Hey, it's me again. I noticed that there are a couple of questions in Slido. So if you want to skip the break and just hang around for the answer. So let me see. So Anonymous says, with auto squash and using the fix up when committing, what if multiple commits match the word you specify? Well, in that case, what Git will do is that Git will automatically move them underneath the right commit, but it's gonna, wait, I misinterpreted. What if multiple commits match the word you specify? Yeah, in that case, Git is gonna move it to the first one it matches, going backwards from the latest commit that you made that contains the fix up exclamation mark in the message. Git is gonna match backwards. The first one it matches is gonna move it underneath that one. So the next one is also anonymous. Any recommendation on how to automatically update the build version numbers in projects before doing a commit? Yes, I have a recommendation. There is a tool that's up on GitHub called Git version. And what Git version does, it ties very well into the discussions I had about different kinds of branches and what environment they're deployed into. What Git version does is that it allows you to define rules that, based on the name of the branch you're on, and by looking at how many commits have happened in that branch since the last tag, for example, Git version is going to automatically generate a version number for you. So for example, let's say that you are in the develop branch and you run Git version on the latest commit. Git version is going to generate a pre-release version number following the rules of Semver, because you are in the develop branch and whatever you have in develop is going to end up in the QA. So it's a preview. By the same token, if you run Git version on the master branch, that's a production branch. And then Git version is going to generate not a preview, but a stable version number. So Git version is the one I recommend to automatically generate Semver version numbers based on the kind of branch that you are on. Yeah, that's it. Thank you again for watching, and I hope you enjoy the rest of the day.